Hello everyone. Today I'll be discussing the LeetCode daily question. So let me just go through the problem statement. And the problem is we'll be given a linked list of size n where n is even and the ith node of the linked list is known as the twin of the n minus 1 minus ith node. So yeah, that is one point they have mentioned. So what is this twin of a particular node is, if suppose we have n is equal to 4, then the node 0 is the twin of node 3. So it is something like the 0th index is the twin of third index. Like, so for the 1th index, it will be 2. So in this manner, we will get the twin of each node, and we need to find that twin sum is defined as sum of node and its twin. So once we know the node and its twin, so when we do the sum of these two nodes, we will get the twin sum. So this is what they have mentioned. And so we'll be given the head of the linked list with the even length, and we need to return the maximum twin sum of the linked list. So yes, this is the problem statement, and we'll try to get these observations and try with the example and get some approach in order to solve this. So we'll do that in my editor. So the first observation that I can make from this problem statement is n is even. So the number of nodes are always even. So it can be something like 2 comma 10 power 5 range. So this is the first observation that I can do from the problem statement. And the second observation is, so twin of ith node is n minus I minus 1th node. So this is the second observation that I can do. So and the third thing is that I need to get the sum of every node and its twin. And at the end, I need to return maximum twin sum I need to return. So these are the four observations that I can make from the given problem statement. So how can I do this? Let's take this example, that is 5, 4, 3, 1. So this is a linked list with n is equal to 4. So what it is saying that, so n is always a even one. So that is for sure for us. And the next thing is that for node 5, that pin is 1. For node 4, that pin is 3. So this is what they are saying. So we need to get the maximum sum possible. So maximum sum possible of all pins. So this is what they are asking. So how can we to get the pin of a particular node? So if I can do some of observations over here, that till here, this is the half part. After this is the second half part. So for this last node, the from the right side, what is the last node that is there? That is a twin. So for this second last node from left, the second last node from right is a twin node. So in order to solve this, if I can have the nodes in this way, that is 5, 4, and here it is something like this at 1, 3, and I can just start here. I can just start here with 2 pointers. Then I can just move and try to add the values and get the sum out of it. But how can I get this part is what we need to do. So it is something that the reverse of second part, right? Second part. So if we reverse the second part, we can able to achieve this. So yes, we can able to achieve this, right? So what I will do in order to solve this, first I need to find the first starting node of second part, right? Node of second part. Second part starting node I need to find. Then after that, reverse the second part and use 2 pointers. Use 2 pointers to use 2 pointers to get some and return max of it. So this is the way that I can think of solving this problem. So for the same example that we have taken, that is 5, 4, 3, 1, right? So I need to get this node, which is a starting node of second part, right? So I need to somehow figure out this node in order to reverse the second part, right? So how can I get the second part first node? Okay. So one thing I can do that something like this, that find entire length, then go to n by 2 node, then the next node of n by 2 node, that is this node, will be our uh, starting node of second part, right? So that will take much time. So if you carefully remember this thing, that the slow and fast pointers, slow and fast pointers will help to find the minimum middle node of our LinkedList. So the same thing that I will do. So I'll start slow here and fast here. And one more thing is that we are sure that n will always even. So if we figure out the formula for any even length, it will work for all the even lengths, right? So start will points to head and fast will points to head. Then after one operation, then it will move to here and it will move to here, or rather here. So fast will move 2 steps and slow will move 1 step. After second one, start will move here, fast will move here. So which is null. So fast will point to null. We will stop there. And if you can observe something, or if you observe carefully here, the start pointer points to the first node of second node. So this is the approach that I will try to implement in order to figure out the first node of second part. So once I know the first node of second part, I will just do this reverse part to this. Let's suppose if I have the above node that is 3, 1, in order to reverse this, what I will do, so I need to change these links, right? Somehow figure out to the, do this thing that I have to change the links. That is, the next of this one points to null and the next of one will points to 3. So this is what I need to do in order to reverse the linked list, right? So for that purpose, we will do this thing that let me just so I will take a dummy node. Uh, I'll take a dummy node which is initially null. So I will take a dummy node which will points to null. Then I will start from here. That is, let's suppose it is current one and this is the next one. So what I will do, I will point the current dot next to this null. So if I figure out this one and then once I complete this and for that I will move my current, then for the next operation also I will do current dot next to this dummy node. Then my linked list will reverse. We will implement the same logic that we have discussed in the website. So the logic that we have discussed is we should find the first node of second part, then we need to reverse the second part, then we will start from uh, first part head and second part head, and we will find the sum of two two nodes and get the max of. So this is the first discussed. So let's first find the uh, first node of second part. That will be, let's consider the slow and fast pointer pointing to head of the linked list. Um, while fast, if fast goes uh, out of the nodes, that is, if it reaches the null, so we need to stop that. If it is not equal to null, we will do slow. Slow will move one point here and fast will move two steps. So it will be fast is equal to fast in the next. So now we are having the first node of second part ready. Now we need to reverse the second part. So what I will do, I will say like this node second head is equal to, I'll call some reverse function with the slow pointer. So this is the head of the second part, right? So I'll say this and after that it will give the reverse one. Then I'll consider two pointers, that is T1 points to head and T2 points to the second part of the head, that is second head. And while T2 is equal to null, we will sum this, that is equal to T1 dot value plus T2 dot value, and we will move T1 to next, T2 to next, T1 next, and T2 to next. So this will get the sum out of it. I need to keep track of max on that. So it will be max is equal to 0. After finding that, it's equal to math dot max of, or it's not sum. In the end, we'll return the max answer that we got. So we need to write this reverse function. So that will be, we need to return a node, right? So that will become reverse of. So we got the head of the linked list. We need to reverse. So in order to reverse that, I will take a dummy node which will points to null. Then I will consider two nodes, or one node, current node, that is list, current node points to head, and while current not equal to null, I will show the next node, that is uh, list. Then it's, that is next is equal to, next node is current dot next, and I will point the current to the main node, that is current dot next is equal to the main node. Then I will move my dummy node to current, and my current points to next. So I'll move, and at the end I will return my dummy node. So this will make sure that the links are changed, and it will give the reverse linked list. Then here we it is not needed, but we will do, because we generally we do not modify the data inside the given data. So we do not need to modify that data. So we will again reverse that data with the second head. I'll pass second head. So it will make sure that the linked list is in the same order that it gave us. So this will be the approach that I will do. So let's try to run this, see if it is final. So it is working. Let's try to submit. Yes, it got accepted. So this is how we will approach this problem, and so in this way we will try to solve this problem. So you can try it out and use the same approach that I have discussed over here. And yeah.